In previous sections, we looked at taking derivatives of individual terms, we looked at power rules, we looked at the derivative of constants, quotients, and products. But what if we have things that don't fit those categories? Now, this example, we could think of this as a product because we could write 2x minus 7 times itself out with 3 of those. But that's more than just 2 factors. It's not just x to a power. So how do we handle this? This is a composition. We have an outside function. We have something to the third power. And we have an inside function. That inside function is 2x minus 7. So how do we handle a derivative of a composition? Remember when we did composition, composition means there's some function that goes on the inside, and then whatever that is, that gets plugged into another function. So in this case, our inside function is 2x minus 7. Our outside function, well, we have something to the third power. So our outside function would be x cubed, something to the third power. So this is being plugged into that. So let's see, how would we handle taking this derivative? Because it's not a product, so it's not just u prime v plus uv prime. So let's do this by making a substitution. Let's replace 2x minus 7 with u. So that'll make this look a little simpler. We could call that u to the third. Now, we could take the derivative of each of these pieces. If we take the derivative of y equals u to the third, our independent variable is u, so we would take the derivative with respect to u. So that would give us not dy over dx, but dy over du. Likewise, if we take the derivative of this piece, our independent variable is x, so we could take the derivative with respect to x, but that's not going to be dy dx, that's going to be du dx. And that derivative is 2. So this gave us the dy, but not dx. This gave us the dx, but not dy. We're wanting to find both dy and dx. So notice, if we were to take dy over du times du over dx, in a sense, the du's would cancel, leaving us dy over dx. So let's see what that would look like. So dy over du would be 3u to the second. Du over dx, that would be 2. Notice this is the derivative of the outside function. This was the derivative of the inside function. So sometimes we refer to this as the outside-inside rule. Whatever our outside function is, which is something to the third power, we have something to the third power. So how do you take a derivative of a power? We bring the power down to the one less power. And then we have an inside component, so we take the derivative of it. But how do we put them together? We put them together, multiply the derivative of the outside times the derivative of the inside. But it's a little bit more complicated than that, because when we do that, what goes on the inside? Well, u, we can't just leave u here. We need this in terms of x. So what was u? So let's write our 3. Our 3 came down to the one less power. That was our outside. We had a 2 over here. That was the derivative of the inside. 7. Of course, we could simplify that and call that 6 times 2x minus 7 squared. But let's discuss that. So in terms of f and g, in terms of g being the inside function, f being the outside function, the 3 and the 2 here come from taking the derivative of the outside function. The 2 here came from taking the derivative of the inside function. But what about the 2x minus 7? Where did that come from? That is the inside function. So when we take the derivative of the outside function, we leave the inside piece as its input, and then we take the derivative of the inside function. So that's our derivative. So let's, now that we have that, so this is the outside, and this is the inside. We saw that could also come from dy over du times du over dx. Especially in this notation, this kind of looks like a little chain. We have 2 layers, but they're connected with this du. Just like when we have a chain, we have 2 different links. They're separate, but they're also connected. Now let's look at this next one, and let's further look at why this is referred to as the chain rule. So here we have several layers, and I'm going to color coordinate this. Our outside layer is that we have sine of something. So that's our outside function. We could call that f. And then we have an inside function. Our inside function is something to the 3rd power. We could call that g. So that's our input to the 3rd power. And then we have something even farther inside there. That 2x minus 4. That's our most inside function. So it's getting deeper, more layers. So h goes on the inside. That goes into g. And all of that goes into f. So how are we going to take that derivative? So let's do it by substitution. So let's replace all of the inside stuff with u. So u is 2x minus 4 to the 3rd power. So we know how to take the derivative of sine. That independent variable is u. So if we take that derivative, du, and the derivative of sine is cosine. Y over du, not du over dx. So we need to take the derivative here with respect to x. Well, this is not just a simple product, or it's not just a simple power rule, so we need to make a substitution here. So let's replace 2x minus 4 with v. We can take this derivative, but that variable is v, so this would be the derivative of u with respect to v. That's 3v to the 1 less power. Our independent variable here is x, so when we take this derivative, that would be dv dx, and that would be 2. So we have here a dy, but no dx. Here we have a dx, but no dy. And also, this variable and this one are not the same, so they're linked by this. So dy over dx, that's going to be dy over du. And that's connected to du over dv, and that's connected to dv over dx. So, in a way, the du's cancel, the dv's cancel, and that would give us dy over dx. So what is y over du? That's cosine of u. So that's the derivative of the outside function. Let's call that the most outside function. And then we're going to take that times du dv. That's 3v squared. Well, where did that come from? That was the derivative of this. That was the derivative of the cube. That was the middle function. And then that's times dv dx, which is 2. Well, where did that come from? That was the derivative of the inside part. The inside part. That was the derivative of 2x minus 4, which is inside there. So the most inside part. So we had the derivative of the outside part is cosine. The middle part was something cubed, so we had the derivative of it, 3 to the 1 less power. And then we had a most inside part, and the derivative of that was 2. But we still have all kinds of variables, so to back substitute. So cosine of u, well, what was u? U is 2x minus 4 to the third. All right, then we have v. Well, what is v? V is 2x minus 4. And then lastly, we have the 2 on the end. So just a quick glance. This was the derivative of what's inside there. All of this, that was the derivative. Well, actually, that even includes that. All of that was a derivative of what was inside there. So the most outside function with its input times the derivative of what was inside. And then the derivative of what was inside, that was the derivative of that function with its input times the derivative of what was on the inside. So we have 3 layers to our chain here. 3 layers to our chain. In terms of f, h, and g, we had the derivative of f with its input times the derivative of g with its input times the derivative of what was inside there. So each time we take the derivative, we leave the input inside there, and then we multiply times the derivative of that. So the derivative of this is all of that. So that g prime, when we take the derivative of g, we leave its input in there times the derivative of the inside. So outside, inside, outside, inside. So let's do one now that's not quite as complicated. Now that we see it's layer upon layer, when we have more than 2 layers, we're not going to try to do all of that at one time. That just kind of gave us some notation for the chain rule, but how are we really going to do it? Not where does it come from, but what are we actually going to do? So when we take the derivative here, we have something on the outside. We have sine. That's our outside function, so the derivative of sine is cosine. And then we're going to multiply that times the derivative of the inside part. And remember, our inside function stays as the input. So this is the derivative of the outside. The input stays inside there. And then we need the derivative of the inside. So that's cosine of x cubed plus 9. And when we take the derivative of the inside piece, we get 3x to the second. So our derivative, we would call that 3x to the second times cosine of x to the third plus 9. We would not multiply that parenthesis times 3x squared because this is inside cosine. That is the input for cosine. Remember, cosine is a function, so that's its input. All of that is times 3x squared. So putting the 3x squared out front takes away any confusion there, hopefully. All right, here we have three layers. We have sine of something, and then that function on the inside has two layers. So how are we actually going to do this? We're going to take the derivative of sine, and we're not going to go ahead and take the derivative. We're just going to say what we need out here. After we take the derivative of sine, we need to take the derivative of the inside part. So the inside part is that. What goes in here, we leave the input inside our function. Remember, this is cosine of something, so this is the input. So the original input stays inside there. So we have cosine of 2x plus 7 squared. And now we need to work on this derivative. Well, how do we take this derivative? We have an outside part. That's something to the second power. So how do we take the derivative of that outside part? We bring the 2 down, and we decrease our exponent by 1. And then we need to multiply that times the derivative of what was inside there. And that inside part is 2x plus 7. Our input, when we're taking the derivative of this function, the input stays on the inside. So the 2 comes down to the 1 less power, but we're leaving the inside function inside. And then we have to multiply times the derivative of that inside function. Well, what's the derivative of that inside function? That's just 2. And then copy everything else down. So we can simplify this. 2 times 2 is 4. That's times that parenthesis. So 4 times 2x plus 7. All of that is times cosine of the inside part. Our derivative. Now we took several derivatives, but this is still the first derivative. We had to take the derivative of the outside, and then the middle, and then the most inside piece to get that complete derivative. So this is not a second derivative, a third derivative. This is still we just had to do each layer. The inside layer, the derivative of the most inside part is 2. That's where this came from. The next layer was something squared, so the derivative of that brought the 2 down, that to the 1 less power. That's the middle. And then the derivative of the outside was cosine. That's the input. So let's do one more. And instead of doing this one, let's change this a little bit. Let's do this. So what is this? So sine squared means sine times itself. The input to sine is 9x minus 4. So when we square that, we really mean this. Whatever sine is squared. So here we have 3 layers. We have this input. That's the input to that. And then that's the input to something squared. So 3 layers. Outside, a layer in the middle, and then the layer inside there. So when we take the derivative of that outside layer involves a power. So to take that derivative, we bring the 2 down, and we do that to the 1 less power. Then we have to multiply times the derivative of what was on the inside. The inside is sine of 9x minus 4. Well, what goes here? So we brought our 2 down to the 1 less power. Remember, the input of that stays inside. So that input is sine of 9x minus 4. Then on the outside, so this is the derivative of the outside part. Notice here we haven't taken the derivative of the inside part yet. So this is the derivative of the outside. That gets multiplied times the derivative of the inside. So for the outside function, all of this is on the inside. So the derivative of the outside, 2 out front to the 1 less power. Inside function is all of this, so times the derivative of that inside. All right, so out front, we have the 2. We have sine of 9x minus 4. All of that's to the first power. All right. Now let's work on this derivative. So this derivative, we have an outside function, which is sine, and we have an inside function. So the derivative of the outside function is cosine, and we have to multiply that times the derivative of what's inside there. What's inside there is 9x minus 4. And what goes here? The inside function stays inside there. So this part is the derivative of this outside, and this is the derivative of the inside of that. Well, what is the derivative of 9x minus 4? That's just 9. Copy everything else down. And then we can simplify a little bit. We have a 2 on the outside, a 9 on the outside. So we could call that 18. That's times sine of 9x minus 4. And that's times cosine of 9x minus 4. So once we simplify, we get this. So multiple layers. Don't try to do too much at one time. Take the derivative of the outside. In this case, our outside was a power. And then write down, what else do we need? We need the derivative of everything on the inside. And then when we do that step, don't try to do all of it at one time. Take the derivative of what's outside there. And then write, once I take the derivative of that outside part, what do I need? I need to take the derivative of what was inside it. The inside part of there is 9x minus 4. Once we get here, there's not a part farther inside, so just take that derivative.